Okay, let's run our app again and see our state. Okay, so we have our app, we have a navigation bar, and we have a basic view controller. Okay, couple things we could start doing. We could change the title of the nav bar. We could call it Programmatic UI. So back in your view controller, in your view did load here, set title bar, set title of navigation bar. And we've done this, right? We said navigation item. We said navigation item that title equal to some string. Here we say programmatic UI. And we have programmatic UI. Okay. Next, I want to add a UI bar button item to the right, and we'll also do it in code here. So add in a UI bar button item to the navigation bar. On our navigation item, we have a left bar button item. We have left bar button items. So it could take in one item or it could take in an array of items. I want to make sure that I say that so that if you want to add more than one button, you know it's possible. So we have a left and we have a right. Again, we could add one bar button item or we could add many. Okay, so I could have an array of bar button items that I put into my nav bar. Okay, so here we just want to have one bar button item, and we want it to be on the right side. So we start off by saying navigation item. Navigation item is in control of everything in the nav bar. As far as I get into the nav bar, you get through it using the navigation item property. And as you see, like we didn't have to, there's no place that we're saying, oh, create a navigation item. Navigation item is part of view controller. Same as we have a view on our view controller has a navigation item, right? And if there's no view controller, that's fine, there's no navigation item, okay? So let's go ahead and set that up. So what type is it? It's a UI bar button item, right? So we start off by saying UI bar button item. And the UI bar button item has different initializers. Here we'll use the one with the image, right? We'll use the one that has an image, so we'll pass in some system image, a minute's favorite gearbox probably, or gear icon, right? We will give it a style, we'll give it a target, and target is where am I looking for the function? When I click on the button, where am I looking for that function? That's what target means. Target is the where. Where am I looking for the function? And the action is the actual function that we'll pass in. We did that before, but here we'll do it again, and we'll see more of that syntax where we're using Objective-C syntax to get, or Objective-C runtime to get to the function we need to get to. That action needs to be a selector, and the selector is the function to look for, right? When I click on that bar button item, very similar to when I drag, control drag from my UI bar button item in Storyboard, I'm connecting an IB action, right? But here we're doing everything in code because we have no more Storyboard. So first we create the bar button item, and then we tell the bar button item what function should you look for when the user clicks on you. Okay, so we set an image. So UI image, we're passing some system image, gear. We'll pass in a style here. I'll call it plain. We'll pass in a target, and again, target could be nil, but in our case, we need to get to the function, so we say self. And self represents what, Jahid? The view controller itself, right? The view controller instance itself. Very good. And then here we have some selector. We'll come back and finish that selector because right now we have no selector. And selector represents the function Selector represents the function that will get called. So here, it will be a settings. It will take us to settings. So we could basically call this function. We'll call it show settings. Show settings. We'll use the same sort of syntax. It's a UI bar button item, and here for now we'll just say print show settings. And now we have a selector. Selector show settings. And let's build to make sure we have no errors here. We do have an error. Objective-C you said, right? Objective-C you said as well, right? Because now remember, it's a runtime. This selector here, it uses the Objective-C runtime. Still uses the old API Objective-C runtime. So I need to explicitly write on line 23 that my show settings is an Objective-C runtime function. So I need to explicitly say at Objective-C. Okay? So here I will say at Objective-C and build. We could take all that code here and put it in a function called configure navbar. Okay. Okay. And simply just call configure navbar here. Keep our view did load simpler. Because everything we just wrote there basically configures the navbar. It sets up the title. It gives the navbar a bar button item, which is to the right of the title. Bless you. So set title for navbar. Add in a UI bar button item to the navigation bar. We give it an image, system image. You could give it an image from your assets as well. We said the style is plain. We said the target is self. Target meaning where am I looking for this method or some method when you click on the button. And the action is the actual selector method here.
So target self means a view controller or this view did load?
Not view did load. Self here represents the view controller. So when I click on the button, it will look for the selector in this view controller. Cool? It will look for the method show settings in that view controller.
Can it look somewhere?
Yes, it could look for somewhere else. You could actually make it nil and then we look somewhere in the project where is that function exist. But we're not going to get there right now. Cool? But for now, itself, self refers to the view controller itself, and the view controller itself has this function called show settings. But yes, it could look someplace else. Okay? The target could be in a different view controller. Yeah. Yeah. Yes, sir.
In show settings, when we use it as a selector, in the parentheses, it's like underscore, like just the colon. Is that like unique to Objective-C? I feel like I haven't seen that.
Here?
Yes.
Yeah. That's Objective-C, the syntax there. You haven't seen that because that's the only place it exists here in that selector syntax.
Will we need it outside of
No.
this like occasional?
No, like if I call show settings someplace else, I have to pass in the button. Right? Like if I say show settings somewhere, show settings, I have to pass in some sort of button. Right? Cool. All right, cool. So we set up our configure bar. Let's see if it actually works. So run the app. And when the app runs, click on your gear icon, and you should see show settings appear in your console. Right? Cool. So everything we need to do in code. The next step is when I click on that button, I want to segue somewhere. Right? When I click on that button, I want to segue. How do I segue? How is that going to work? Okay? So now we'll move show settings here, and we want to say segue to the settings view controller. How are we going to segue? Right? Any ideas? Present would be one way, like if I want to present it over, like slide over. What if I want to push it? Push. What do I need? I need some sort of view controller. But what am I embedded in something? What am I embedded in? I'm embedded in a navigation controller. So the navigation controller object here is optional. Why is it optional? You don't have to be embedded in a navigation controller. Very good. Because a view controller, it has all those properties. Some of them are optional because the view controller doesn't have to be embedded in anything. If it's not embedded in a navigation controller, the navigation controller property will be nil. So here, I have a navigation controller. I'll say push. I'll say push view controller, and then I need to pass in the view controller I'm going to. The view controller I'm going to is the settings view controller, right? We'll create an instance of the settings view controller. What's the difference between line 30 doing in code and line 30 that we did last week with storyboards? What's the difference? Anybody remember? What's the difference here? Yes, sir. We have to set up an identifier, right? Because we were getting the settings view controller from storyboard. Everybody? Right? But here, there's no storyboard. So our settings view controller, we set it up in code. There's no initializer right now. We just use the default initializer. But not today, but later, we'll see that we could use settings view controller and pass it some property or some argument. For example, if we go in from a New York Times books view controller or whatever, we could pass a book. Or if we go into like a Pixabay thing, we could pass a photo. So this settings view controller could take in arguments, okay? But we're not going to get into initializers on view controllers right now. But today, the basic is just to get our view set up. Yes?
So could show settings become a comparative segue? Like the same way we did settings dot in property?
Yep. Think about it like prepare for segue. Very good. So if I want to pass in information, if you're doing it in code, I would recommend against saying, for example, settings. I would not do that. Settings vc dot default image, for example, and then you pass it some default image, right? In code, I would not do that because you have the power of dependency injection, which we'll get into, not today. But here I could say settings view controller, you need a default image. So I'll give you a default image like that. Default image. So I wouldn't do line 31. I would just do line 30, which is more object oriented, right? The thing needs an object, you give it that object, and that's it, right? And that object itself is private, right? But we'll get there. That's where we headed, but that's not what we're doing today.
Can you explain
Line
line 31?
31? Oh, that's fine. So line 30, we all understand line 30, right? Line 30 says, I create an instance of my settings view controller. Questions? One, line 30, we create an instance of settings view controller. Okay? Line 31 says, my navigation, I'm embedded in a navigation controller. Now, I'm embedded in a navigation controller. My navigation controller now could push a new view onto the stack. Meaning, basically prepare for segue.
So why, why are we using navigation controller instead of like usually we segue from controller to?
Yeah, but now we don't have storyboard, right?
Yeah.
And then when the user clicks on that button, we need to segue them. We need to transition them from view 1 to view 2.
Yeah, so from view, why from navigation controller?
Because navigation controller now is the owner of this view controller.
Okay. Okay.
Navigation controller is the one pushing, not the view controller doesn't have a push property on it.
Okay. And so we're basically saying that we're pushing view to another.
Remember with our stack data structure class, right? We said a stack to add something, you push, right? So the navigation controller now is the manager of this view controller, right? So if I want to add something new to the navigation stack, I use the navigation controller. If I want to add a new view controller onto my scene, like the user wants to go to a new view controller, it's embedded in the navigation controller. And if I want to use a push segue, I have to say navigation controller, push this new view controller onto the stack.
Okay, so if you would not embed, you would use
If I
that
did not
view
embed-
controller, that push view controller?
If I did not embed, the view controller is not in a navigation controller. The only way you could transition is using present. Right? Right? Assuming like you only have one view controller in storyboard, how do you transition from A to B? There's no pushing anymore. You would not get a back button. Do you agree? You have one view controller.
Oh, okay, yeah.
You have one view controller. You navigate from that view controller to a different view controller. Do you have a back button? No.
Okay.
Right? So it presents it modally.
So it would be like, what did you say, present?
Yeah, present. Yeah, present. Cool. Any questions about, so what Yuli was asking was why navigation controller, and walk her back through what exactly it does. So the navigation controller object is optional because your view controller might not be embedded, your view controller might not be inside of a navigation controller. But if it's inside of a navigation controller, and you want to push or you want to have that back button on your UI bar, you use navigation controller push view controller. Okay? Questions? Greg, you had a question?
I was basically going to reiterate that. At a minimum, this allows us to retain like the back button when we actually.
And also have that transition,
Right.
that transition looking like, right, from left to right.
So essentially, we want to stay within the navigation controller, which is why we're going to get that.
Yes, but if you want to, you could still do modal presentation,
Sure.
right? But here, we just want to push it, similar to like when we in storyboard and we segue from a nav controller to a next controller, it will just give you the back button there. So that like one line of code, it does exactly that.
So
Yeah.
when we would like to present modally, what would you use instead of push view controller? Modal?
Same as when we have our alert controller, we would say present settings, right? With our alert controller, we say present, right? And it just presents it modally.
Okay.
Modally is from bottom up, right? You could have a transition there. There's many transitions you could use. You could make the thing curl. You could do different transitions. But it's how you want to present your UI.
Yeah, I just like to know like different options how they're possible programmatic.
Exactly. But on that, later, there's other ways. There's transition modes, like you could make your thing fade in. There's other things you could do with the present there. All right? Cool.
Did you say the default for present is the mobile presentation?
Yeah, like slide up. But on that transition, you could change the animations there. There's a modal transition style. Like maybe you could make it curl. You could make it fade. Yeah, exactly. Maybe we show it on Thursday or something. Or just play with it, right? So it's present, settings, view, modal, presentation style. And then you could play with that number here. There's automatic, current context, form sheet, full screen. And there's also, 1 second, that's for your own notes. And settings, I could say presentation style. Modal presentation style, modal transition style, and flip horizontal, partial curl, You could try those too. But all those are presenting. I'll just keep them in here for notes, so you could test those out. But for now, we simply just want to push. Okay? All right, so let's test this out and see what's going on. So when I click on my settings button here, it pushes my view. Right? So now I have that back button, and I have my settings controller getting presented. Everybody, you should now see your settings controller. Do we all see our settings controller? Tiffany? Right? Okay, cool. And I could go back, see my view controller. Great. Okay, next step, let's go create some view elements. Very similar to, we want now a label, we want a button. How do we get that into our UI? Right? So our UI will be very similar. It will have a text label in the center, and it will have a button to reset the values. The app we're building is a simple app that has some colors. I could go to my settings, I could pick a color, and that color becomes the default color of the application. So I'll have a picker view in my settings that chooses the color, and when I choose that color, it changes the background color of the app, right? So if I chose orange, it changes everything to orange, right? And on my main view, I'll have a label showing the current color and a reset button. What will the reset do? When I click reset, it goes back to white. Okay? So that's where we're going. That's where we're headed. But we need views for that, right? We need views for that. So let's see. Should we rename our view controller main view controller? Maybe we do. Let's refactor the view controller here. Refactor, rename. From view controller, name it main view controller. Enter, bless you. So main view controller is our first view controller, and we have a settings view controller. For each of our controllers, we'll create a subclass of UI view. For each controller, we'll create a subclass of UI view, and in those views, we will set up our labels, picker view, whatever we need. Okay? So each of our controllers will have a separate view class, and in that view class, we'll have our elements. We'll have a label and a button in our main view, and for our settings view, we'll have a picker view. Settings will have a picker view. Okay. So let's go create a view. Right click, new file, CocoaTouch class, and it's a subclass of, what did we say? UI view. Subclass of UI view, we'll call it main view. This is the first time we're subclassing UI view, if I'm not mistaken here.
Yes.
Very good. So here we're subclassing UI view, and we say next and create. Great. We take out any boilerplate code we have here. And this is our class. Class name is main view. It subclasses UI view. So UI view is the parent. Main view is the subclass. We need to use the initializer for the frame. We need to give the view a frame. Again, we're doing everything in code. We need to give our initializer some frame, our view some frame. Very similar to what we did with window, but here we're using the override initializer on a view to give it some sort of frame. We'll call super init with frame. And init with frame, as our UI window, takes in some CGRect. What are we going to pass here for the CGRect if we want to take the entire view? UI screen, right? So we'll go ahead and we'll say UI screen here. .main, .bounds. Great. Xcode is still complaining. Because back in unit 1, or end of unit 1, We said there's default initializers, there's required initializers. Here, Xcode is telling us we are required to also implement or also provide this required initializer on a view, right? Why? Because it's saying, hey, if I'm coming from storyboard, I need to have some sort of initializer as well. If you're going ahead and you override in or you subclass in UI view, you need to also, I'm not going to say fix it here. We'll just type in required. Type in required init. And for here, just pass in super.init with coder. Init with coder, this initializer comes from storyboard. So if this view gets initialized from storyboard, this initializer gets called, right? And here, this initializer, the init with frame initializer, gets called if view is done programmatically, right? So your view could either come from storyboard or from code. We're doing everything in code. What initializer gets called? Init with frame, right? So this initializer is the one that gets called. If it's coming from storyboard, init with frame doesn't get called. Which initializer gets called? Init with coder, okay? To make that even read better, we'll create a function here and we'll call it common init. And common init we'll call from both places. Bless you. Okay. So regardless of where it comes from, whether it be in code or storyboard, we'll have this common init set up any code we have, right? Set up any code. Any logic we need to do, we have a common initializer function that does that. Okay. So to recap, init with frame gets called if your view is being done in code. Init with coder gets called if your view is being done or called from storyboard. That same view we have here, we could have that view embedded, or we could go to storyboard view and change the class in identity inspector to our main view class. Everybody with me, right? At that point, it would call the required init with coder. Yes?
Why is it required init march with
It's a failable initializer. It could fail. Remember back in Unit 1, we created failable initializers. If it doesn't have a value, it will return nil, right? Very good. So the init question mark is going back to Unit 1. Initializers there, review initializers there. That's a failable initializer. It could fail, right? And if it fails, that means it comes back nil, and that object doesn't get created. Yes?
Can't the first initializer fail if the second one isn't? If the second one is activated and it's not done programmatically?
In our case, there one or the other gets called, not both.
Okay.
Right? Be careful there. Right, so either we're coming from code or we're coming from storyboard. We're not coming from both at the same time.
Okay.
Cool? Very good. All right, perfect. Cool. So we have our setup code here. Let us go ahead and create a label. What do we say? We're going to create a label, and create a button, right? We need to create a label, we need to create a button, and we'll create both of those using lazy variable syntax. We'll create both elements using lazy vars. And why we're using lazy vars? Because we'll create it as it's needed. It will load as the view gets initialized and as it's called. It will only get created when it's called. So let's go ahead and do that. So we'll start off by making it public, and we'll say lazy var, and what label is this? We'll call this message label. Message label is fine. Message label is of type UI label. Message label is of type UI label. And we'll use closure syntax here with a return. And we'll talk about what's happening as I finish typing out what's going on. So we'll say label here equal to UI label and return label. So before I continue, let's talk about what's happening here. Okay, so we created a lazy variable to instantiate our message label. Our property is called message label. Message label is of type UI label. In our closure syntax, we define what the label is. We say label is of type UI label, and here we actually initialized it. This is not initializing anything, right? UI label does not initialize anything. It annotates what the thing is. This is type annotation. Line 15 is where we actually create the label, where we actually initialize the label. Line 15 initializes the label. And line 16 returns that label object to whoever called it. And at the end of our closure, we have a method call, right? So we're actually calling the actual closure. Whenever I say dot message label, or anytime I call message label, it returns that object to me, right? It's done lazily, meaning it's done when it's needed. And lazy vars are very powerful. They allow us to do things like this. So if I have some private, actually, that's good. I could create, let's create a message, default message. If I create a default message here and I call it no default color set, please go to settings, for example. Right? Please go to settings. So here, that allows me to do things like this. If it's a lazy variable, this is allowed. I could say label.text equal to default message. Right? If the variable is not a lazy variable, this will give us a compiler error. Right? Let us see what that looks like. If this is not a lazy variable, if message label is not a lazy variable, we are not allowed to use an instance property. We are not allowed to use an instance property in our variable. If it's not lazy, I cannot use default message here. Right? Let's see what that looks like. If we just create some variable here, call it some label. This is for testing. Some label is of type UI label. And I say let label equal to UI label, return label, and I try to say label.text equal to default message, right? If I try to do this without my variable being lazy, you see the error now, right? There's an error saying instance member cannot be used on type main view. In other words, the instance at this point, it doesn't know the value. I cannot use this value. That value does not exist. Everybody with me? This is very important. That value does not exist. But if I make my variable lazy, lazy means it will get created after the main view got initiated. After the main view gets initiated, and as I need my message label, the message label will get called. So this is different. So line 22 is different than line 16 because line 22 attempts to create everything right away. This creates the sum label right away. But it takes a look at default message. It's like, hey, I can't create this yet. The instance hasn't been created. So this does not work. But with lazy, it waits when the instances got created. Then, as you need message label, it will get called. Right? So that's the big difference between lazy var and a regular var. Right? Lazy vars allows you to use instances before they got called. Okay? Or not use instances before they got called, but it won't get called until the instance got created. Right? So the lazy var, it's guaranteed that the instance will exist before the body gets executed. Yes, sir.
So first, why aren't we just setting the label? Why aren't we just instantiating it like in the first line? Why are we doing it within like the computer property brackets?
You mean like here?
Yeah, like instead of doing like UI label, because basically it's returning to itself that label.
It's returning to the object, not to itself, to the object calling it.
Okay.
Right? So when we, in our code, we say add subview message label, that's when it gets called.
So is that specific to the fact that it's lazy, or is that just whenever?
Not lazy, because as we see, like this is still okay.
Okay.
Right? The two of them are okay except line 24. But with the way we lay out our views, we want to lay them out such that we lay them out structurally and we lay them out as we need them, because what we'll do later is constrain them based on the way they appear in the view.
So can you repeat one more time? So when it's that only happens when it's called, you said?
Yeah, this line 17 to 19 only happens when I say add subview message label.
Okay.
Okay, we'll see that later in the code, but right now message label doesn't get called at this point.
Okay.
Right? There's no place I'm getting called here.
Is that important? Why is it important that it's not called earlier?
Because we'll just create it as we need it.
Okay.
Right? So as we need it later in our code here, we'll see it. So like for example, in our command init, we'll say add subview message label. We add it, we call it, it gets added. Right? There could be a variable that we might not need. We don't have to call it. But the lazy var allows for performance. You only use it if you need it. Right? Cool. Yes.
So once it's called, it gets the value.
Yes, once it's called, this gets executed, it gets the value. But not before.
And the second.
The second one attempts right away. Everything gets executed with the instance. Right? Awesome. So let's just put a comment here. And this does not compile, right? You see this on the exam, does not compile. If you see code like this, the first thing you should look at is it a lazy variable? If it's a lazy variable, it's fine. You could use default message here, right? If it's not lazy, it will crash, or not crash, it will give you a compiler error. Yeah.
Is it the parentheses at the end that is the reason that it's only
This?
that the code only activates? Yeah.
Yeah, so let's talk about that here. So this is actually calling the function, or calling the type. So create a closure and calls simultaneously. Right? So the minute I say I'm trying to access message label, it creates the label and it calls this block of code. Right?
So if that was removed, it would.
If that was removed, well, that would be a compiler error because the compiler is expecting some call at the end because you have a return here.
Yeah.
Right? So that's what, it's like 2 in 1. It creates it, it calls it at the same time.